Hello everyone. In this video, let us see some problems on uniform distribution. See the first question. If x is uniformly distributed with a mean value means it is given as a plus b by 2 is 2. Variance is given by 12. Variance formula is b minus a the whole square divided by 12 is given as 12. After this one, we have to find p of x less than 3. So if it is so, we can write a plus b is 4 and b minus a the whole square is 144. Taking square root on both sides, we will be getting b minus a as 12. If a plus b is 4 and b minus a is 12, minus a plus b will be 12. So we will be getting 2b is equal to 16. Our b value will be equal to 8. If b is 8, then we can conclude our a value will be minus 4 by substituting in either of the equation. So after that, we can write the PDF of our uniform distribution, which is nothing but 1 by b minus a. 8 minus of minus 4 will be getting 1 by 12 and the limit is minus 4 to 8. The question asked is, we are going to find the probability of x less than 3. So probability of x less than 3, normally the definition is minus infinity to 3 f of x dx. But the lower limit is already restricted with minus 4. So it is integral minus 4 to 3 f of x dx. F of x value is 1 by 12. We can take it outside. If we integrate 1, we will get x, and substituting the limit, it is 3 minus of minus 4. It will be 3 plus 4. It is 7. So the answer will be 7 by 12. Let's see the next question. Metro trains are scheduled every 5 minutes at a certain station. So the time limit is 5 minutes. A person comes to the station at a random time. Let the random variable x count the number of times he or she has to wait for the next train. Assume x has a uniform distribution over the interval 0,5. We are going to find the probability that he or she has to wait at least 3 minutes for the train. So it follows uniform distribution in the interval 0,5. So PDF f of x will be 1 by b minus a, which is 1 by 5 minus 0, which is 1 by 5. So the range is from 0 to 5. The question asked is, we have to find the probability that he or she has to wait for at least 3 minutes before the train. So listen, the train arrives at every 5 minutes. Okay. 15, etc. If one has to wait for at least 3 minutes, so if he come by first minute, what will be the waiting time? It is 4. He can come. Okay. If he comes by second minute, what will be the waiting time? At again 3. If he comes by fourth minute, the waiting time is not true. So we are going to find probability of x greater than or equal to 3. So it is 3 to infinity f of x dx, but the ceiling value is 5 here. So we are finding integral 3 to 5. F of x value is 1 by 5 dx. We can take this 1 by 5 outside. Integral of 1 will be x. 5 minus 3 answer will be 2. So our final answer will be 2 by 5. Next question. 4 buses arrive at a specified stop at 15-minute intervals starting at 7 a.m. That is, they arrive at 7, 7:15, 7:30, 7:45 and so on. If a passenger arrive at the stop at a time, the uniformly distributed between 7 and 7:30. So note that between 7 and 7:30 a passenger arrives. So already at 7:15 one bus will leave. So what is the probability that he has to wait less than 5 minutes for a bus? So if he arrive after 7:10, so this is 7:10, this is 7:20. If he arrive after 7:10, he will be able to catch the next bus. If he arrives after 7:20, he will be able to catch the next bus is 7:30. 30. So there are two possibilities. One, he has to arrive between 10 and 15. Next one, he has to arrive between 25 and 30. Restricting the limit, we can put 10 to 15 and 25 to 30 in limit part. 1 by 30 can be taken outside. 15 minus 10 answer is 5. 30 minus 25 answer is 5. So 5 plus 5 will be getting 10 plus 30. The final answer is 1 by 3. See the next one. What's the probability that a passenger has to wait for more than 10 minutes? So if we are dealing with more than 10 minutes, then he must have arrived before 7 and 7:05, and also 7:15 to 7:20. Then only he'll be waiting more than 10 minutes for the next buses 7:15 and 7:30. So the limit is from 0 to 5 and 15 to 20. So the difference is same. We'll be getting the answer 1 by 3. Next one, the passenger has to wait at least 12 minutes means, so this is 7, this is 7:15, this is 7:30. At least 12 minutes means from 0 to 3 he must have arrived between 0 to 3. Here he must have arrived between 7:15 to 7:18. That is 7 hours 15 minutes to 7 hours 18 minutes. So the integral limit is from 0 to 3, and here the integral limit is from 15 to 18. After substituting of the PDF value and taking that 1 by 30 constant outside our integral value, subtracting 3 minus 0 will be getting 3. 18 minus 15 is 3. So the total is 6 divided by 30. The answer will be 1 by 5. Actually, this is very important problem in uniform distribution. Thank you.